have a look at type 5. I have a resistor, I have a capacitor, and I have a combination of ramp as well. So let's obtain the signal for I of t. When I see that my input are having a ramp, are having a delta function or sine function or a unit step signal, it straight away indicates me that I need to solve by using a Laplace. So for Laplace, I just need to start directly at t greater than 0 plus. The circuit which you get is this. So let's convert into your Laplace domain. For converting this into Laplace domain, the new formula which you need to know is, for converting C, the formula is 1 upon Cs, and for L is nothing but your Ls. Your R remains as R. So your circuit which you get is plus minus 2 will be as it is. R of t will be 1 upon S square, and t minus 2. So minus 2 will be e raised to minus of 2s. In series with the resistance 3 ohms, a capacitor which you have as 1 farad. The value for C is 1, so it will be 1 upon S. So over here you will be getting I of S. Add both of them, so you get 3 plus 1 upon S into I of S equal to, the current enters in negative, so it will be 2 upon S square e raised to minus of 2s. Simplify to get I of S. If I need to get I of S, my dear friends, so I of S will be equal to 2 upon S square e raised to minus of 2s into, shift it down, so the equation which you get is 3 plus 1 upon S. So I of S is equal to 2 upon S square e raised to minus of 2s. This will be shifted over here, it will be 3s plus 1 upon S. Shift S upstairs, so in numerator, so this will be 2 into e raised to minus 2s into S upon 3s plus 1. Since I need to apply Laplace inverse, the coefficient of S should be 1. So take a 3 as common. So I of S will be equal to, cancel 2 upon S into e raised to minus of 2s whole upon, take 3 as common, this will be S plus 1 upon 3. So the value which you get is 2 divided by 3 is 0.66, and 1 upon 3, that is nothing but as, you can also do it as 3 inverse. So your I of S will be equal to 0.67 e raised to minus of 2s whole upon S into S plus 0.33. So apply the partial for this so that we can apply inverse for the equation. For partial, you don't need to consider the exponential because you need that term to apply inverse. So you will be applying partial only to this term. So this will be a upon s, and power is 1. This will be b upon s plus 0.33. So value of e is nothing but equal to, take the term as it is, 0.67 upon s into s plus 0.33. So for a, take the denominator as 0, s equal to 0. So put the value of s equal to 0, you'll get the value for a. So the value for a which you get is 0.67 divided by 0.33. So value which you get is 2.03. Similarly, you'll be finding the value for b, my dear friends. So value for b which you get in this case is b, the whole function, 0.67 divided by s into s plus 0.33. For b, the denominator, take it as 0, so s will be equal to minus 0.33. So value for b in numerator you have 0.67 divided by, and denominator the value for s you have minus 0.33, close bracket, the value for s is minus 0.33 plus, in this case, so the cancellation will be this, so it will be 0.67 divided by minus 0.33. So the value which you get is 0.67 divided by 0.33, so minus 2.03. Similarly, in an earlier case, when I had to find out s, so this will get cancelled because function of a will come in numerator term. Put the value of s, so which you will be getting 0.67 divided by 0.33, and the value you will get as 2.03. So put the value of a and b, my dear friends, in your equation of I of s. Your I of s will be equal to, in this case, will be e raised to minus of 2s bracket. Your a is 2.03 upon s. Your b is again minus 0.23 upon s plus 0.33. So your I of s will be equal to, open the bracket, which you get e raised to minus of 2s into 2.03 whole upon s minus e raised to minus 2s into 2.03 upon s plus 0.33. So by taking the inverse Laplace transform, you get as I of t is equal to 2.03 is a constant. So 1 upon s, you write u of t, and you have an exponential e raised to minus 2. So that is shifted over here. Minus 2.03. You have 1 upon s plus 0.33. That means first for s plus 0.33 will be e raised to minus 0.33 t into 1 upon s will be t. Again you have exponential in numerator. So for exponential in numerator, the t will be shifted by minus 2 and minus 2. So that's the equation which you got after solving the function when you have a resistor and a capacitor and a ramp signal. So hope you enjoyed. Please start practicing for this kind of sums. Utmost important, and let's have a few more example on in case of capacitor. Thank you guys. Signing off.